Junction. Yes, sir. Now live streaming started.
Yep.
Yes,
Yeah, it started now.
Okay. Thanks for reminding me. Yeah, I thought it was started in like. Okay, no problem. So is my screen visible now? Visible, right?
yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what I was saying is, I was talking about sets, right? So in the sets, the first thing that I told you was each
Hello?
of the yeah.
Can you repeat irrational number?
So I told you, right? So rational number is simply any number that you can write it in the form of p upon q, where q is not equals to 0.
Irrational number.
Rational number, and anything except that is irrational number. Okay. So that is basically the complement of rational number, right? So that is, you call it as a irrational number. Clear? So see, whenever you are writing irrational in the form of a decimal number, right? So it every time it will be like without repeating number you'll be getting. Okay. But I hope that makes clear, right, to you. Is it clear or not?
Yes, sir.
Okay, so I was talking about sets, right? In the sets, I was saying that uh, the first thing that I told you was each of the elements that are present in a set that you call it as an element. And the second thing that I told you was the order doesn't matter in a set. Okay, so the order of the items that is present in a set or order of the element that is present in a set doesn't matter. Order doesn't matter. Okay. And whenever, yeah, so, and the third thing that is the most important is, let's for example, you're writing duplicates in a set, right? That also doesn't matter. So whenever, let's for example, you have been given a set 1, 2, and 3. Okay. So if you have been asked to calculate the number of the element that is present in a set, that you call it as a cardinality of a set. Okay. So here the cardinality is 3. Okay. The number of items that is present in this set is 3. So if you have been given something like 1, 2, 2, and 3, that is nothing but equals to, you can just write it as 1, 2, 3. So here the duplicate doesn't matter in a set. Okay, so if the duplicates is also present, right, you will not be double counting that. If you have been asked to calculate the cardinality of a set that has a duplicates present, you will not be counting that duplicate. So here also, if you have been said, right, here also the number of unique elements you'll be counting. Okay, that is basically 3 here. Okay, so the duplicate doesn't matter in a sets. When we'll be coming and writing the relations, okay, between two sets, then we'll see that the order there will matter, the duplicates also will matter. Okay, but here if you have been just given a set and then the order doesn't matter, the duplicates doesn't matter, and each of the element or the item that is present in a set, that we call it as an element. Okay, so these are the 3 important things about the sets. I hope that makes sense to you.
Yes, sir.
Correct?
Yes, sir. Right.
Okay. What do you mean by subset then? Subset also you would have heard of a word subset.
Set which is made from the parent set.
A part
Okay,
of
so
Every
correct, yeah.
elements of the set contains the parent subset.
Yeah.
A set
A set.
which contains all the elements of a set. Like
Right.
B is called a subset of A if all the elements of B are in A.
Not all the elements, but
No,
some
not
elements.
all
That
the
is so
elements.
wrong.
No,
B is called the subset of
Okay.
A if all the elements of B are in A.
No,
Okay,
not all elements are required.
Okay,
Yes,
got
he's
it.
correct.
Whatever.
She's all the elements of B in A.
She's
Then she's
right.
totally
Yes,
correct.
that is what I'm trying to.
Okay. Yeah. She's right. So let's say example, a set that you are defining, a set X is a subset of another set Y. Let's say example, you're just giving it as a Y. If every element of X is also an element of Y. So that is what you are saying. And how do you denote? This will be denoting as. There's something called proper subset also. I'll tell you, but first you should be clear with the subset. Everybody is clear, right? So a set X or A, any whatever set that you have been given to you, that is a subset of another set Y or anything else. Okay, if every element of X, okay, if you're writing like this, that means whatever like element that is present in the set X is also there in Y. Let's for example, I'm just giving you one example. X is equals to a set 1, 2, 5, 7, 9. Okay, and Y has been given as, let's for example 1, 2, 5, 7, 9, 170. Is X a subset of Y here?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
Yes.
Correct. So
Yes,
all the
sir.
elements that is there in X is also present in Y. Let's for example, this is example 1. Let's for example another example 2. If you have been given X equals to 1, 2, 3, 4, and Y also is 1, 2, 3, 4. Here is X a subset of Y?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
X and Y both are same sets, right?
Correct. So here also it will be applicable. But another concept that you call it as a what? Proper subset.
Proper subset.
What is the difference here?
Sir, in proper
Sir,
subset,
the
both the
Y
sets should
has
not be
an
equal.
chance to be equal. Y has
Yeah.
an extra elements
Correct. Here,
rather than
yeah, here there is only one extra thing, that X can't be equals to Y.
Yeah.
Okay, that's the only thing that is different from the normal subset. Okay, so here a set is a proper set. If X is a subset of Y, but there is only one difference, that X should not be equals to Y. Correct. And the denote, how do you denote this? You will be denoting as here, because you can't have a equal, right? So that's why we'll just denote it as it is. So X is a proper subset of Y. Okay, so the first example here. Okay, so in the first example, what do you say, whether X is a proper subset of Y or not?
Yes, sir.
it's a
Yes.
Yes, sir.
subset.
Whatever the
It's
second
a proper
example,
subset.
whatever the second
Example
is
is not a
No,
proper.
sir.
No, sir.
This is not a proper
It's
No.
subset.
not a proper subset.
No, sir.
correct. X is not a proper subset of Y for the second example, and I hope this is clear to everybody.
Yes.
Okay. So now I hope this was pretty simple from the perspective of a set. Let's deal with the relations. Okay. So in the relation, and so till now whatever we have discussed, okay, mostly in the exams and all, nobody generally asks you regarding the natural number or whole number or sets and all. Okay, but from relation, every time you'll be getting some 1 or 2 questions in your paper, and this time also you'll be having some questions for sure in relation. You will be given some sort of a conditions, and then or a different type of a relation, 3-4 relation you will be given, and then you will be asked to like asked regarding whether the relation is symmetric or not, reflexive or not, transitive or not, or equivalence or not. Okay, so this you will be asked every time. Every time you'll be writing, and you can just check the previous term papers also. In each of the previous term paper, you'll be having one questions from the relation. So this topic you should be knowing very nicely. At least should be knowing whatever the relation has been given. You should be able to pick out whether the relation that has been given to in the question is symmetric or transitive or reflexive or equivalence. If all threes are present, then you generally call it as a equivalence relation. Okay. So let's deal with that. Yeah.
Sir,
Mm-hmm.
sir, before going to relation, can you clarify my doubt that there is in lecture the instructor said that is rational number is greater than integer. These types of questions they are raised and said we will discuss this later, but I totally get confused. Can you clarify that why we can say that rational numbers are greater than integers? These types of
What
questions.
rational number is greater than?
मतलब cardinality of rational numbers are greater than integers and cardinality of real numbers are greater than rational numbers. These types of questions they have raised in the lecture.
Cardinality of, okay, maybe after this, in the end, we can discuss that, whatever the question that you have, right?
Okay, sir.
In the end of the session, you can stay after the sessions, okay? But I
Okay,
don't think so. There is anything questions like cardinality of rational number greater than or less than. I don't think so. Those are any questions. But even though you can just let me know in the end of the session if
Okay,
there
sir.
are any questions and like that. Okay.
Okay.
So let's say example. So we'll start with the relations now. See, in relation, there's nothing. This is also a very basic concept. You can be given two different sort of a set, right? The two different set. Okay, just give me. Just give me a minute. My pencil is not working. Okay. Yeah. So what I was saying, let's for example, you have a Are you guys able to hear me? I don't know what is happening.
Yeah,
Yes, sir.
Yeah, we can hear you.
Yes, sir, we can hear you.
Sir has left the chat or what?
Just take
No, no.
a while.
He's there, but he stopped sharing.
Like what?
Let
And
minutes.
Okay. Okay. No, my pencil was not working. So just give me a second.
Yeah, sure.
What is happening? It's not working when it is live. Yeah, I guess it's working now. Yeah, so what I was saying, whenever we are dealing with relations, okay, so you'll be having two different sets, right? If you have a two different sets, let's for example, you have a set X and Y. So you can have, and so whenever you are writing some sort of a relation, right? So generally you are writing some sort of a ordered pair. One, you're taking it from a set X. Okay, so you have a different n number of values that is present in set X. Okay, and there is a set Y also present. There also you have a n number of or elements that is present in set Y. Okay, and whenever you are writing some sort of a ordered pair, let's for example you're writing X comma Y, where X is been coming out from set capital X and small y is coming out from a set of capital Y. Okay, so you'll be having some sort of a relations. Okay, so let's for example this is a R1 relation where this X is coming out from a capital X and this Y is coming out from this capital X relation, and this is coming out from the capital Y set. Okay, so this can be one sort of a relation. Okay, you can have an n number of relation that you can write it out. Okay, depending upon how you are deciding the relation, right? This X can be, let's for example, Y can be X square, or Y can be some sort of a relation Y equals to X square, and this can be a R2 relation. Similarly, you can have a R3 relation where this Y3 can be X cube also. Okay, so what you'll be doing, you'll be picking out one of the element from one of the set and the another element from the another set. Okay, and then whenever you'll be writing, that will become some sort of a relation. Okay, and that relation can have some features, right? That relation can be symmetric, reflexive, transitive, or whatever. But this, first of all, you should be knowing that this relation is nothing but some sort of relation that mapping I have decided, and then what I am doing is picking out one element from one set and then the another from the another element, and then there is some mapping has been done from my side itself. Okay, that mapping generally you call it as a relation. I hope this gives you an idea about the relation. Okay, see, whenever, let's for example, you're writing.
Hello.
Yeah.
So sorry for interrupting. Can I get this live session from recorded from YouTube?
Yeah, it's going on. It's going live on YouTube.
No, can I access this from tomorrow?
Yeah, you can access anytime.
Okay, thank you.
Yeah. Okay. So what I was saying is there can be any n number of mapping that you can have. Mapping you can have from set X to set Y, and that mapping itself you call it as a relation. Okay. Now, just I want to give you some example. Let's for example, the first example. You have been given a set A. And a set B as 1, 2, 3. See, whenever I'm writing, see, the one of a very basic concept is Cartesian product also. So Cartesian product is nothing but all the combinations. So what I'll be doing in Cartesian product, I'll just taking out, let's for example, one element I have just taken out from one of the set A and the other element from the other set. So this, then A2, A3, B1, B2, B3. So these are what all the combinations that can occur. Okay, so I've just taken out one element from the A and the other element from B. Okay, so A1, A2, A3, and similarly B1, B2, B3. So this is what? This is generally all the different type of relation that can exist between set A and B. So that you call it as a Cartesian product. And this you generally represent it as A cross B, where you're just taking out one element from one set and the other element from the other set. Okay, so this is nothing but all the different type of relation that can exist, okay, between this A cross B. A cross B is nothing but a Cartesian product. Okay, I hope you know the idea. And relation that you are making, R1, R2, any different type of relation that you are making, that is nothing but some sort of a subset of A cross B itself. Okay, so A cross B is the whole chunk of mapping that can occur between these two sets. Okay, and when you are writing R1, R2, R3, okay, this R1, R2, R3 that I can write it is generally the relation R1, R2, R3 will be from this whole chunk itself. Okay, this whole bigger set itself, A cross B. Is this clear to everybody?
Yes, sir.
Yes, sir.
Sir.
Right?
Yes, sir.
Sir.
Clear.
Correct. So this, yeah. So this set A was A comma B. This was having Cartesian, yeah, cardinality of 2, and here it was cardinality of 3. So the whole different type of mapping that can occur is 6. Okay. And from this 6 itself, whenever, let's for example, you're just taking out A1 and B1. Okay. This will be one sort of a relation. Okay. That relation, the mapping can be of a different type, but this can be one sort of a mapping. Similarly, you can just pick out A1, A2 or A1, A2, A3 or any number of things that you can pick out from the 6 element, and then you can just define it as a one sort of a relation. Okay. Later we'll see that whenever from this Cartesian product you are picking out some of the relation, whether that relation itself becomes a function or not. Okay. So that we'll be learning later. But first of all, we should be knowing that if you have been given two different sets, so from the two different sets you'll be having some sort of a Cartesian product that contains the whole chunk of mapping that can occur between these two sets. Okay. And that whole Cartesian product, if you are just picking out some of the mapping from those Cartesian product, that will be defined as some sort of a relation. Okay. Now let's have an example. Let's, for example, I just told you this was generally the whole chunk of Cartesian product that can occur. Okay. Let's define one R1 relation. I'll just pick out A1, B2, and B3. This is one relation, and you can see that all three are coming out from this Cartesian product A cross B itself. Clear? Similarly, you can have R2, R3, n number of relation that you can write it out, and that all those you can just pick it out from the Cartesian product that you have A cross B.
But sir, as you said that
Yeah.
y might be the square of x or might be the cube of x.
Correct.
Then that particular relation is not from the Cartesian product now.
No. See, let's for example, I'm writing y equals to x square. Okay. But here, the domain or codomain I have not defined yet, right? See, let's for example, any number that you are taking, I'm just giving an example where the number minus infinite to infinite is present in one set A, and in one set B, the number is from minus infinite to infinite. Okay. So now whenever you will be making A cross B, what do you think? If I have a relation y equals to x square, that will not come under A cross B. It will be there, right?
Yes, sir. Yes. Yes,
You got it, right? See, let's for example, I'm making a one relation where x is 1, then y will be 1. If x is 2, y will be what? 4. Correct? In x is 3, y will be 9. Similarly, it will be similarly the square of all the values. Here, because we have all the values from minus infinite to infinite, for sure 1 comma 1 will also be there in A cross B Cartesian product, right? Similarly,
Yes, sir.
2 cross 4 will also be there. Even though we'll be having 4 cross 4, 1 cross 2, everything will be there, but 2 cross 2 will also be there. Similarly, 3
Yes,
cross
sir.
9 will also be there for sure, right? So that is what I was talking about, where I have not defined the domain and codomain. Correct? So if, let's for example, all the values are present here and all the values are present in the B set, if you have the Cartesian product, then for sure you'll be having, then you can have this also as a relation. Okay, but this y equals to x square can't be defined here, because here you already know that all the value, only 6 values are present. Okay, so from this itself, you can have one relation like this. You can have another relation like, let's for example, A2 comma A1. This can be your one relation. Okay, but you can't have y equals to x square here, because you can just think, right, one is alphabetical number and the other is numerical number. So you can't define y equals to x square here. Okay, but you can define y equals to x square if you have a, yeah.
So, sir, can I say that the relation depends on domain and codomain?
Yeah. If it all depends on the Cartesian product that you have, A cross B.
Okay, sir.
You got it, right? Yeah.
Yes, sir.
So these are all relation that has been, so it all depends on set A and set B that you have, right? Any relation you are making. So let's, for example, you have a set A and you have a set B. So any relation that you will be making out, right? A mapping, some sort of a mapping, right? That you will be making out from A to B itself, right? And if, let's, for example, you just have A1, A2 here and 1, 2, 3 here. So any relation that you are mapping, like any mapping that you are doing, right? That can have what? A1 times 1 or some sort of A2 times 2. It can't have 1, 2, because 1 is not in the domain itself, not present in set A. So whenever you are making A cross B as a Cartesian product, I told you one element will be from one of the set and the other element will be from the other set. Okay, then only you can have some sort of a mapping that you are making, right? And that mapping itself, you call it as a relation. Is it clear to everybody?
Yes, sir.
Is it clear to
Yes,
everybody?
sir.
Yeah. Okay.
Yes, sir.
Yes, sir. Okay. So now, so when I was talking about the relation, so this is clear. So now this relation can have some sort of a features also. Okay. If that reflects some sort of a feature that is defined, like let's for example, a relation that depicts some particular type of a features, then you call it as a symmetric. Another type of a feature that you call it as a reflexive, and the another type, then you call it as a transitive. Mostly we are just learning about 3 things only, not more than that, not less than that, right? So these 3 you should be knowing very nicely. Okay. So let's for example, I deal with the first feature. Okay. When you call it as a relation R1 or R2, anything a relation R as a reflexive relation. Okay. This you should be knowing. So first we are just talking about a reflexive relation. So any relation that has been defined, okay, any relation, let's for example, a relation R be a relation on any set, on set S, okay. If R be a reflexive relation, so this reflexive relation on set A, one and only when if and only if for all the values, for all element that is present in S, so maybe I'll just write it in a better way. For if and only if for, let's for example, element that is X that is present for all X that is present in S, right? XX should be present. I'll just make it clarify this. Let's for example, you have been given a set S, and that S set consists of 1, 2, why this is not working, 3, 4. Okay. So you have a set S that is having a cardinality of 4 that contains 1, 2, 3, 4. Now you have to make a relation R, and where, so let's for example, you have a relation, so S is their set and you are making S cross S itself. So you'll be having 1, 2, 3, 4 element here, 1, 2, 3, 4 present, right? And there is some sort of a mapping that you're doing. Okay. And after doing the mapping, you are calling that there is some sort of a mapping R. Okay. And that R mapping or a relation, whatever you want to call it as, a reflexive relation, only if and only if for, let's for example, an element that is present X. So any element that is present X that is present in S, okay, this bigger set 1, 2, 3, 4. Okay. So if that is present, like X is present, then XX should be present in R. So let's for example, one example. Why this is not... Okay. So what I was saying, you just think in that way. See, if you have been given a mapping S cross S mapping, a set S has been defined where 1, 2, 3, 4 is the element of S. You have defined a Cartesian product, okay, S cross S, and then you have been said that a relation R has been defined here that contains 1, 1, 2, 2, 3, 3, and 4, 4. You have been asked to tell whether this is a reflexive relation or not. How will you check that? You just have to check any element that is present in S. Okay, there is a condition on S. Okay, let's for example 1. So I just said you X, right? That means what? Let's for example 1 is present in S. So 1 1 should be present in R, and that is applicable for each and every element of S. So let's, for example, here it is 2. So 2 2 should also be present in R. 3 is also present in S. So 3 3 should be present in R, and 4 4 should also be present in R. Okay. So there is a condition, all right, for each and every element that is present in S. Okay. XX should be present. So if 1 is present in S, 1 1 should be present in the relation R, then only it will be a reflexive. 2 2 should be present, 3 3 should be present, 4 4 should be present. Okay. 1 2 is present or not doesn't matter to me. The only thing that matters to me to make this relation a reflexive is what? 1 1 2 2 3 3 4 4. Apart from those four, anything else is present doesn't matter to me. Is it clear to everybody or not?
Yes, sir.
Yes, sir. Yeah.
Yes.
You got it. So here it has been said that any relation R is a reflexive relation if and only if each and every element that is present in the set S, capital S, okay, this XX should be present. If that means what? X is what? 1, 2, 3, 4. If let's, for example, that S was having 5 also, 5, 4, then only if 1, 1, 2, 2, 3, 3, 4, 4 was present, that was not a reflexive because it needs 5, 5 also. Are you getting me? So for, okay, now let's, for example, this S has 1, 2, 3, 4, 5 as element. What do you think? Is this relation a reflexive or not?
It's not.
No, sir.
It's not because 5, 5 is not present. Correct, because 5, 5 is not present. All right. Now, let's, for example, I'm just writing 1, 2 and 2, 3 and 5, 5. Now, is this relation reflexive?
Yes, sir.
This is reflexive because we just have to worry about each of the element that is present in S. So 1, 2, 3, 4, 5 is present in S. So in our reflexive relation R, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 should be present. I don't care about anything else. Okay. 1, 2 is present or not, 2, 3 is present or not, 4, 5 is present or not. You don't have to worry about those things. You just have to check for each and every element that is present in S, XS should be present. That's it. If here 6 was present, then 6, 6 you need. If 7 were present, you need 7, 7. Apart from that, 6, 7 is present or not, 1, 1, like 6, 5 is present or not, 5, 4 is present, doesn't matter to you. Only this, for each and every element of X that is present in S, XX should be present. That's it. That is what you have to check it. Nothing else. Is this clear to everybody, the reflexive relation?
Yes.
Can you go ahead?
Yes.
Yes,
Okay.
sir.
Yes, sir. Clear.
Yes, sir.
Yes, sir.
So here 1, 2, 3, 4 has been given to you. R1, R2, R3, and R4. Now you have to tell me which of the following are reflexive. So here 1, 1, 2, 2, 3, 3, 4, 4. 1, 1, 2, 3, 2, 2, 4, 4, and 3, 4. 1, 1, 2, 2, 3, 3, 4, 4, 3, 4. Okay. So which of the three are reflexive?
1 and 3.
R1 and
R1 and
R1 and R3.
Okay, correct. So this is reflexive and this is reflexive. R2 is not reflexive, and I hope everybody
R1
is
and
convinced,
R3.
right? Correct, correct. Okay. Now let's move to the second.
Sir,
features
can you
of a
explain the difference between
yeah.
reflexive and identity relation?
What?
The difference between reflexive and identity relation.
See, in the identity, you just need this 4. Okay. Apart from this, you don't need 4, 1, 1, 4, and all those things. Okay. So but in a reflexive, apart from this 4, if you have anything else also, that doesn't matter to it. That will be a reflexive, but that will not be identity matrix, relation. Okay. You got it, right?
Excuse me, sir.
Yeah.
Sir, I have a question. Why R3 is also the example of the reflexive relation as it is more than the 3 digits of the 4 and 3?
No, this is what you're talking about. 3, 4.
Yes, sir.
No, this is what I said. For a reflexive relation, right? This 4 should be present. Apart from this 4, anything else is present doesn't matter to it. So this 4 is the most important thing. So
Sir,
It
one
means
more
both
thing.
at same
yeah.
digit. Thank you, sir.
Sir, one more
Yeah.
thing. Can we say that domain should be the subset of codomain for reflexive relation?
No. So see, the one thing is domain and codomain. Those are totally different things.
Those come under functions.
Function.
Yeah. So those are two totally different things. You can say that for a means you can't like compare between domain and codomain, but yeah, you can say something about the range and codomain. Okay, so the range will always be a subset of codomain. Okay, that you can say, but not about the domain and codomain. I hope. Okay, we'll discuss about that when we'll be discussing about the function, not now.
Sir, we can say that the first elements of these relations are domain and the second element is correct.
That you can say the first element from where you are starting. So the pre-image that you can say it as a domain, and this you can call it as a codomain.
Yes, sir.
So the expected outcome is the codomain, and the input that you are putting in the function is the domain. Okay, we'll talk about the range, the exact output that you are getting after the domain. You call it as a range. Can you please
Yes.
mute yourself?
Please
I
mute the
hope.
mic.
Sir, there is a background noise.
Yeah, can you please mute? Yeah, I hope this. Thank you. Yeah.
Sir, one doubt is,
Yeah.
so identity relation is a subset of the reflexive relation.
Yeah, that you can call it.
relations?
Yeah, that is correct. So let's, for
Okay.
example, you have R equals to 1, 2, 3. Okay, so the identity matrix will just be 1, 1, 2, 2, 3, 3. You can't add anything else here. So this is identity, but this is identity and reflexive both. Reflexive can have 1, 1, 2, 2, 3, 3. Apart from that, you can have 1, 2 also. Okay, but this will be reflexive. But this is identity and plus reflexive both. Okay, clear, right?
Sir, I was
Okay,
saying
but
that
this.
hello,
Yeah.
sir. So I was saying that to establish reflexive
Go
relations,
ahead.
like first set should be, I mean, one set should be obviously the subset of the other set. Because for that, to map and have that identity relation for the reflex set, we need one to be subset for the other, to be the subset of the other set.
Subset of the other set. I didn't get your point.
Sir,
Are you
I'm
talking about
saying
domain and codomain or something else?
say we are having two sets A and B, and we have two elements in both. So if we want to establish a reflexive relation between the two, uh, I want to say that either A or B should be subset of each other. I mean anyone, like A should be the subset of B. So then only we can have a reflexive mapping.
Yeah, that you can call.
Yeah. Okay, sir.
So see,
Sir,
the second thing.
Sir, what
The
he
second
asked, I
thing.
didn't understand. What are you asking? What he is asking, I didn't understand.
No. He is talking about if, let's for example, two totally different sets are there, right? Then you can't have come out to a conclusion that this is a reflexive relation. This is what you are
Exactly, sir.
talking
Exactly,
about.
sir. Yes,
Yeah.
sir.
Okay. Now.
Yeah. So the second thing, the reflexive is done. Let's come out to the symmetric relation. So the second is symmetric relation. So here also, let's for example, relation has been defined. Let R be a relation on the set S, and yeah, then this R relation is said to be symmetric when, if and only if for every element, for element that is present in this relation R, okay, implies Yx should also be present in this relation R. See, so in the reflexive, what I was talking about, there is a condition on S, okay, the bigger set on which we were doing the mapping and all. Here, there's no condition on S. Here is just a condition that, let's for example, you have a relation S was something like 1, 2, 3, and 4. Correct? So, if let's for example, relation R has been given to you, that is 1, 2. So here it is what it's saying. If xy is present in R, then yx should be present. If xy is present and yx is not present, then you can call it as this is not symmetric. So first example, 1, 2 is present. If 1, 2 is present, for sure 2, 1 should be there. If it is done, then you call it as a symmetric. There is no condition that for each of the element that is present in S, the opposite should be present. Here it is just told that if 1, 2 is present, 2, 1 should be present. So R2 relation. If 1, 2 is present, is this R2 or symmetric relation? Is
No,
R2 a
sir.
symmetric?
No, sir.
No.
So one
Why?
should be present.
Sir.
Because 2, 1 is not present.
So one
Correct.
should.
Now,
2 is not related to
1, 2
here.
is there, 2, 1 is there. Let's for example, 2, 2 is there. Now 2, 3 is there. So what do you think? Is R3 a symmetric?
No,
No,
sir.
sir.
No, sir.
3, 2 should be there.
Three two should be there.
Correct. Now if I'm writing 3, 2, is R3 symmetric?
Yes, sir.
Yes.
Yes, sir.
Yes,
It
sir.
will be symmetric.
Correct. Is R4 a symmetric?
Yes.
Yes,
Yes.
sir.
Is R4
Yes,
a
sir.
reflexive?
Yes.
Yes,
Sir.
sir.
I mean,
Reflexive.
No,
Yes,
sir.
sir.
Reflexive.
no.
No, sir, it's not reflective.
It
It's
is.
not reflexive. Is it
No,
identity?
sir.
No. Identity should.
No. What?
It
Yes.
is-
No,
It is
no,
identity, but
it's
not
not.
reflexive.
No, it's not identity.
It should be having for identity. Each and every element should be present. 1, 1, 2, 2, 3, 3, 4, 4. All the things should be present. Okay.
Okay, sir. It is neither reflective, neither identity.
It is only symmetric because 1, 1
Yes,
is
sir.
present. So xy is present and yx is also present. Okay.
Yes.
Clear, right? I hope
Yes.
this is also clear.
sir.
Yes, sir.
Sir, one basic question, sir.
Yeah.
Yeah, sir, you said yes as 1, 2, 3, 4, right?
Yeah.
So we have one set. Now you are taking X and Y. So X is also coming from yes and Y is also coming from yes, or is
Yeah,
there any other
because
set?
we are talking about the binary. Yeah, we are just talking about the binary relation where you have S also as a domain and S is a codomain also. Okay. So the Cartesian product that we are making, that is generally S cross S itself.
Okay. So it is possible that it need not be S and S all the time, right? It can be.
Yeah,
A-
it need not be. Yeah. No, it need not be. Yeah, correct.
Okay. So from two different sets, when we are making pairs, I mean the Cartesian product, the relation, that is the relation which you are defining. It is not always the same sets, correct? Is that
No,
correct?
yeah, correct. Yeah,
Okay, sir. Thank you.
Okay. Now the third feature of a relation can be
Sir, what
a
about the
transitive relation.
number of elements?
Which number of elements?
The number of elements in the different set that we take, it should always be same, is it?
Number of element in which set? Okay, you are talking about this one, huh? To
Yes,
all
sir,
this
yes.
thing.
Relation.
No,
if
so
we
let's
are
for
considering
example.
two different sets.
Yeah, so let's for example, see if you are mapping right from set A to set B, correct? So let's for example, this mapping you have defined as x square, y equals to x square, correct? So if you have defined some mapping, so only one element you will be, when you will be mapping, right? Let's for example, you have taken 1 from x. So this is x, this is y, correct? And you are making some sort of a mapping where mapping is y equals to x square. This is some sort of a relation. Let's for example, here it was 1, 2, 3, 4, 5 till 10. And here it was 1, 2 till 10. Correct? So now if you have defined one relation, so one value you'll be taking out from x, right? So if you're just taking x equals to, say, you're defining something like xy, right? So where y is what? X square. So if you are defining 1, 1, similarly 1, 2, if you are taking x, then it will be 4. Correct? So this is one
Yes, sir.
relation R1. Are you getting? Yeah. So you can have only two elements, right? Because you are just making only, if let's say example, you are like, you can have, let's say example, 3, 9, right? You can have, let's say example,
Yes, sir.
minus 2 was there, and here it was 4. So you can have minus 2, 4. That is possible. But in whenever you are defining some mapping, at one point of time, you'll just be taking one value, right? And then the outcome after the mapping will
Yes,
be
sir.
only
Yeah.
one, right? Yeah, that is what I talk. So whenever you're defining some sort of relation, you'll be having like only one mapping you can have, right? This mapping can be anything. Let's say example, a mapping is y equals to mod x. This is also one sort of a mapping itself, right? Where you are just taking x ka value and you're just putting some sort of a mod. So you can have 1, -1, 1 here, like 0 here, and you can have 1, 2, 3 here. So some sort of a mapping you're defining where y equals to mod x. So whenever you are taking 1, so you'll be having outcome as 1 only. Whenever you are taking -1, then also the outcome will be 1 only. But this is mapping. Like this is one sort of a mapping. Whether it's this mapping is function, not function, and all that we'll be learning later. But this is one sort of a relation. Okay, that relation can be anything. Is it clear?
So you mean
Yes,
to
sir.
say
So basically,
so the elements in the relation are something which satisfies the condition which you have put, correct? Sir?
Correct. Any condition you can put, anything, any arbitrary condition you can put, any mapping you can put, and that will be one sort of a relation. That relation will fulfill symmetric characteristic or not. That depends upon like whatever we have defined as a symmetric or reflexive or a transitive and all. Okay.
so as
Sir,
long as the element is present in the other set, like that we want to map, like if as long as the condition is satisfied, it doesn't matter the number of elements, right?
Yeah. No. See, a number of element. What you are trying to say, I'm not able to understand. But whenever you are mapping something, right, there will be one input, there will be one output for sure, right? There is only one mapping that you are doing, right?
Yes, sir.
Correct. So there will be one input, one output. Let's, for example, you are just defining y equals to x square plus bx plus c. This is a mapping, correct? This is some
Yes,
sort
sir.
of a
So
mapping. So for one,
sometime like
go ahead.
we can have like two different elements can be mapped to same number in the other
That
set.
can be mapped. That I'm not saying. Like I'm not asking about that. See, there can be a mapping of y equals to x square, right? Where if you are putting -1 or 1, you'll be having the value as 1 only. But this mapping, how will you write? You'll be writing -1, 1, correct? And then 1, 1. You can't write it as -1, 1, 1. Nothing like that, right? Are you getting me? So
Yes, sir.
this is a mapping y equals to x square. This is some sort of a condition that you are applying on your domain, and then you are getting some sort of a output. That is one sort of a mapping. That is relation only. Okay. Any relation you can have it, right? You can have, let's for example, a name a. This, let's for example, some Rohit, Mohit, Sohit, and then you can have some other name, and then you can define, okay, these are the brother or sister, whatever, and that is also one sort of a mapping that you are making, a relation that is come out to be correct.
Yes, sir. So my
Yeah.
original doubt was that in the two different sets that we are trying to map, the
Hmm.
number of elements in the first set and the second set,
Can be
is it
different.
all is necessary
No,
that
it's
they should
not
be same?
necessary. No, it's
Okay.
not
So
necessary that will be
ultimately, it
same.
is about mapping, na sir?
Correct. So this is the every confusion that you have, whether the number of this element A and B, this can be different. Yeah, it can be different. The number of A can be different from the number of B. For sure, it can be, right? You can have a
Yes, sir.
element 1, 2, 3, and here it can be 1, 2, 3, 4, 5, 6, 7 also. So here also there can be a mapping between these two. That is possible. Okay.
Sir,
Okay, sir. I got
sir,
it.
one
Thank
last
you.
doubt, sir. Sir, if the
Yeah.
assuming that in first set 1, 2, 3 is there, second set 5, 6, 7 is there, then we can never get it to be a reflexive condition, right, sir? Because we will never find 1, 1, no, sir.
So
What if-
reflexive, reflexive condition that we are defining it, that those we are defining on a binary relation. Okay, binary relation. When will you get the binary relation? When you have a set S. Okay, S cross S, the Cartesian product that you are making, right? That is S cross S itself. Okay.
When we are doing the Cartesian product of the same set, that is
Correct.
when
Correct.
reflexive will come.
Yeah. Mm-hmm.
Sir,
So
one thing, sir, do we have to map all the elements from the first set to the second set?
Those are not compulsory. So any number, let's for example, only one relation, y equals to x square. You're just making minus 1, 1. That's it. This can also be a one relation.
Okay, sir.
That's not compulsory to have each and every element should be mapped to the another one.
Okay, sir.
You got it right? Okay.
Yes, I got it.
Okay, so just give me one. Just wait. I'll just give you one question that maybe clarify your doubts and all. Okay. Okay, I hope so. There is, let's for example, one example where it has been defined. Let's for example, there is 3 level of schools or maybe classes: level 1, level 2, and level 3. So just think of as our degree itself. So this is foundation. Then you have a diploma. Then you have a degree. Okay, and then you have a BS, but that doesn't matter. So as of now, so in level 1, let's for example, you're learning now as maths and stats you are learning, correct? Now you'll be learning, let's for example, in diploma, you'll be learning one of the course, machine learning. Okay, ML you'll be learning.
Programming.
Okay. Okay. In one of the degree courses, you'll be learning, like for example, you're learning DL, deep learning you are learning. Okay, and then advanced algorithm you'll be learning. Okay. So in level 1, you have learned all these things. Level 2, you have learned machine learning, basic machine learning, and then you are learning deep learning, the level 3.
Sir, and AI?
Now, no, I'm just giving you an example. There are a lot of subjects. I'm just giving you an example. So now, let's for example, I'm just defining one relation R, where the relation R that I'm defining is A cross A, comma B, such that, okay, and one more thing I'll tell you. So, and in the degree, that is a requirement that if you are finishing the foundation, then only you'll go to the diploma. If you're finishing the diploma, then only you'll be going to the degree level. Okay, so for this, go to opt for this basic machine learning, maths and stats is the prerequisite. Okay, so whenever you're going to the DL, if you have to learn DL, you'll have to finish the diploma. So basic machine learning. Okay, I hope this is clear to everybody. Now a relation that I'm defining R as some sort of a relation where the relation is written in the form of A cross B, like A comma B, where A and B are courses in same level. Okay, and there is one more relation. This is R1, this is R2. The other relation that I'm defining is A comma B, where it has been, so whatever you're writing A comma B, where A and B are in the course in the same level, and then you have a relation A is prerequisite of B. Now you have to tell me which of the two relation, R1 and R2. Now you tell me all the things. So you have learned about symmetric and you have learned about the reflexive, right? R1 is reflexive or not?
R1 is reflexive because we have A and B from both from the same set, maths and stats.
Okay, you're right. So whoever was having doubt, just let me know. You just think it of now. Whatever I said, okay, I'm just asking what reflexive relation, right? Now, it has been said that a relation has been defined R1, A comma B, where A comma B is what? A and B are the courses in the same level.
Yes, sir.
Correct? So this can
Yes.
be a reflexive relation or not?
Yes, sir. This can be a reflexive.
It
This
can
can
be
be
reflective.
correct. This
Yes,
can be
sir.
reflexive, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
R1 can be symmetric or not?
Yes, sir.
Yes,
Symmetric.
sir.
Yes, sir. Symmetric.
Yes, sir.
R can be symmetric
It
also,
may be.
Yes.
right? So
Yes,
symmetric
sir.
was
Can be
what? If
symmetric also.
xy is present, yx should be present.
Yes,
So
sir.
if AB is in the same level, BA is also in the same level, right? The course is in the same level, correct?
Yes, sir.
Yes, sir.
Got it, right?
Yes,
Is this
Yes,
clear
sir.
to everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. What about the R2?
We have
Not reflexive.
so they are not reflexive and not symmetric as well.
These are not reflexive, not symmetric as well, correct?
Yes.
Yes, sir.
Got it, right?
Yes, sir. Yes.
Okay. And in the exam, you'll be getting this type of a problem only. Okay. So this type of a problem, you can just practice as much as you can.
Can you explain how R2 is not symmetric and not reflexive?
Okay. See, R2, A is a prerequisite for B, right? So for a symmetric, what should be the condition? When do you make a judgment that this relation is a symmetric or not symmetric? For X, if AB is present, BA should be present, right?
Sir,
Correct?
each
AB
element
belongs to
opposite
R
should be
and
present.
then BA belongs to R. Then it is symmetric.
So let's for example, one course that you're doing maths. For maths, something like let's for example, you're doing ML. For ML, maths is prerequisite. For maths, is ML prerequisite?
No, sir.
No, right? So this is not symmetric.
No.
Correct?
No.
Not
Okay.
symmetric.
You got it right.
Yes, sir.
So now the third thing is the transitive relation. Okay, how many of you know about the transitive relation? So we'll have to pace it up because we have to do function is also
Yes,
left,
sir.
right?
If A is related to B, then B is related to A.
No.
A is related to
If
B.
A is related
B
to B,
related
No.
to
If A is related to B, then B is related to C. I
Then
think.
A is
Then
related
B is related
Let R
to
be a
C.
binary
also be
relation
related.
If
on set
A is
S.
related to B, then B is related to A. That is.
No.
No,
No.
sir.
No.
If
Sir,
A is
A
related to
is
B,
related
B is related
to
to
B,
C.
is
No,
related
then
to
B is
C,
related
B is
to
related
C.
to C, then A also related to C. A to
Okay, yeah. So whoever is saying, yeah, this is correct only. See, let's for example, you are just defining one relation, then R is said to be a transitive relation if and only if for every pair of element, let's for example, a pair has been given xy, okay, and if xy and yz is present, then
XZ must be present.
xz should be present in R. Is this clear? So xy and yz is present, then xz should be present. Just
Yes.
listen. So yeah, xy yz is present, then xz should be. If only xy is present, then you don't have to worry. That is also transitive. Okay. So xy yz is present, then only you have to check for xz. If only xy is present, you don't have to check for anything else. Now I'll give you one example. So the same thing, s equals to 1, 2, 3, 4. Now let's for example, a relation has been given 1, 4. Is this a transitive relation?
Yes, sir.
Yes, sir.
Yes,
It is
sir.
a transitive because
Yes.
what did I say? For xy, so here xy is what? X equals to 1 and y equals to 4. So for this case, I don't have yz, so I don't have to worry about xz. Correct? So now the second case, R1. If 1, 4 is present, 4, 3 is present. Okay. So if 1, 4 and 4, 3 is
Not
present, is it a
transitive.
transitive relation?
No, sir.
Not
No,
transitive
sir.
relation.
Because
No.
correct, because 1, 4 is present, 4, 3 is present, so 1, 3 should be
Be
present.
there.
If 1, 3 is present, then you can
Then
say
it
that.
will be a transitive relation.
Yes,
Sir, is
sir.
it 1-3 or 3-1? Or it doesn't matter the Order matters no.
No,
Sorry.
one
Order
one.
matter. Order
Matters.
matter. I told you, right? One more thing. In the
Relation
set
mapping.
when you were learning, the order was not mattering. But here in the relation, 2 1 is not equals to 1 2. Because everything will change, right? 2 1 is what? 2 is having some sort of a mapping with 1. Here 1 is mapping with 2, right? This is totally
Right.
different, right? If you are, let's say, defining a mapping y equals to x square, that means what? If you have 1, then you are getting 1 as output. If you have 2, then you are getting output as what? 4. You can't equate 4 2, right? If you'll put 4 here, you'll be getting 16. Are you getting me? So 2 4 is not equals to 4 2. So in a
Yeah.
relation, the order matters. Okay, in the set it was not mattering, but in a relation it matters.
Sir, now if
Clear to
instead
every-
of 1 3, if we have 3 1, then it is not transitive, no, sir.
It's not transitive.
Okay, sir.
So let's for example 1 4, 4 3, and 3 1. Is it a transitive? No.
No, sir.
No.
No, sir.
No, sir.
No.
Now you have 2 4, 1 2, 1 4, 4 1, 1 1, 2 1. Is it a transitive relation?
No, sir.
No.
Because 2 is not
It is transitive.
It is
It is
transitive, sir.
transitive. It is transitive, sir.
It is transitive, sir.
It's not.
It is.
Yes, sir. It is transitive.
Okay, let's check it.
Yes, it is transitive.
It's not, sir.
One.
Okay, let's
It's
check
not
it. Okay.
transitive.
Okay, so for 2 4, okay, just give me a second. I'll just, so 2 4 4 1.
4
So
1.
for 2 4, 4 1 is there. So 2 1 should be there.
Yes,
It is
sir.
there, right? Now, okay,
One.
let's come to the second part. 1 2 is there. Is there anything that starts with 2? Yeah, it is there.
2 1.
Right? So 1
One.
2 is there. 2 1 is there. So 1 1 should be present. 1 1 is present.
Yes.
Correct. Now let's come to 1
4.
4. Anything that starts with 4? Yeah, 4 4 is there.
No.
So sorry, 1 4 is there. So 1 1 should be correct. That is also
Yeah.
fine. Now,
Sir, should all the elements satisfy the transitive or is
yeah,
there...
every element should satisfy. That's why I wrote, right? Each and I said to be transitive if for every pair of element. Okay, that condition should be satisfied. X Y Y Z Y X Z should be present. Okay. So now for this case,
4 1.
I hope this is
Sir,
transitive, right?
can you explain to R only 1 4
What
how to
what?
transit? R only 1 4 then transitive or
Okay.
not?
Yeah, R 1 comma 4. What was the
Yes.
condition? Here the condition is what? Is for every pair of element. X for every pair of element. That means
Sir.
XY is present and YZ is present. Then you have to search for XZ. If only XY is present, you don't have to search. Like YZ is not present, right? Then why you have to check for YZ itself? XZ
Okay.
itself. You're getting me, right? So
Sir.
see,
Yes.
only 1 4 is present. That means this is XY. You don't have anything XZ, right? Then this is transitive itself, right?
We don't have to check.
Correct.
Okay.
So yeah.
Sir,
So
sir,
R3
I have
is
one
what?
doubt.
R3 is transitive.
Sir, I have a doubt.
It is not because we have
Sir,
4
2
1
2 is not.
R3
and
is
4.
transitive.
4 4
is not present.
2 2 is
What?
not present.
4 4 is not there.
2 is not present.
In 2 1
4 is
and
also
1
not
2.
present.
For
4
2
1
1
is
and
there.
1 2,
Correct.
2 2 is
All
not present.
elements are
Yeah.
satisfied.
Thanks. Yeah. So
R3 is not
2
transitive.
is interesting.
so this
Yes, good
XY,
point.
right? And this is XZ, right? Then 2 2 is not present, right? And if 2 2 is not even the one condition you have not able to get it, then it is not transitive.
4 1
Okay, so
and
fulfill.
1
also 4 4 not
yes.
present.
4 4 is not present. Yes.
Yeah, even 4 4 is not present. So if let's for example this is XY and this is YZ, then 4 4 is not present. Correct. So 4 4 is also not present. So you just have to find out one. If you are able to find it one itself, then you can directly say that it's not transitive. Okay, got it?
Yes, sir.
Yes, sir.
Any doubt in any of the cases? No, right?
No, sir.
No.
Yeah. Okay. Let's, for example, you have been given some sort of a questions where R1 and R2 is a relation that is defined on S process. So everything will be given. So you don't have to worry about what is this S and all. So wherever it has been given, everything will be given to you. Okay, you don't have to. So let's, for example, R1 and R2 is defined on S process.
Excuse me, sir.
where R is, just give me a second. So where R1 is written like x comma y and xy, such that x and y is coming from what? Is coming from S. And they're defined as y equals to 3x. And R2 okay, this is there, right? S is also been given. S is something like that is A, where A belongs to natural number and less than equals to 10. Now you just tell me the R1 relation itself. I don't want anything else. I just need R1 relation. R1 relation is what? Is defined in such a way that it is defined in x comma y, where the mapping is what? Y equals to 3x. And where it has been defined in some sort of a relation S cross S. What is S here? S is something A that is less than equals to 10. All the natural number that is less than equals to 10. So 0 is included. So if you just miss out 0, your answer will change. So I'm just asking what is the cardinality of R1. So the number of
4.
element that is present in R1.
It's
4.
3, 1, 4.
4. Cardinality is 4.
सर 3, 1 होगा और एक
3 sir, 3.
0,
Sir,
3, 6,
Zero
9.
repeat the
9.
question,
0,
please.
0, 0.
What I'm asking is, there is some sort of a relation R1 is defined on S cross S. Okay, on a Cartesian product of S cross S. Now, what I'm saying is, R1 is what? R1 is a relation that is written in the form of x comma y, where y is what? There is a mapping that has been defined, y equals to 3x. Okay, you got it right? And then S
Yes.
is what? If you need the S set, because you need S set, right? S is what? S is all the element that is less than equals to all the natural number that is less than equals to 10. Now I'm asking, what is the number of elements?
3 elements.
Cardinality of R.
Cardinality is 3.
3 elements.
0, 0,
3
1,
elements.
3, and
0,
3,
0.
9.
So whoever is saying 3, right? I guess that is incorrect.
Is the correct answer.
They're not including 0, 0.
Correct. I told you, right? 0, 0 you have to include, right? Because that in the natural number includes that, right? 0. So the answer will change, and that will happen in the exam. I'm like many of the students will do the same. So here, what I'm saying, S is what? S is any value that is less than equals to 10. So all the natural number I'm talking about. So 0 it is included. Okay, 0 to 10.
Excuse me,
Correct.
sir.
Now you have to define R1. What is R1 here? Y equals to 3x. If you are putting x equals to 0, you are getting right 0, 0. If you will put x equals to 1, what will you get?
1,
1,
3.
3.
3, 1,
If you are putting x equals to 2, what will you get?
2, 6.
6.
If you are putting x equals to 3, what will you
3,
get?
9.
3,
3, 9. If you will put 4, right, what will you get? 12. Is 12 present in S cross S?
No, sir.
No. Right? So that will not come, right? Then what is the number of cards? This 4 values are there, right?
Cardinality is 4.
Yes, sir.
Values.
Now I'm asking R2. R2 you have to define it. You have to just tell me the cardinality. Okay. Here R2 is defined as x comma y. Okay. Where x, y both coming from S cross S. Okay. And now a relation has been defined as y equals to x square. Now tell me the value of R2. Number of cardinality of R, number of element that is present in R2. Number of element, you don't have to count 1, 2, 3, something like that. This is 1. Okay.
So
3 or 4.
Four.
Again, doing the same
Three,
mistake, right?
4 is again.
Is 4, sir.
4.
0, 0,
4.
1, 1, 2, 4,
and
3, 9.
The cardinality will be 4.
Cardinality is 4, sir.
4. How many if you are saying 3? 3 should not be the answer, because I told you, just now I told you, 0, 0 again, here also it will be there. 0, 0 it will be there. Now I am asking, R3 is a relation. Here it has been said x comma y. Xy is coming from S. Y is equals to x square plus 1. Now tell me the value, number of element present in R3.
3. It's 3.
4.
4, sir.
4.
4,
4,
sir.
sir.
10 is
4.
included, so
It was
4.
less than 10, sir. Less than equal to 10.
Less than equals to 10, correct? Yeah, so
4.
10 is
Armath is
Less than
4,
4.
sir.
Sorry, sir. 4.
It's my turn.
It's my bad. Sorry.
okay.
10.
4.
Okay.
Then it is 4.
Okay, so anybody has any doubt in this? No, right?
Yes,
Can
sir.
you move?
I have
Yeah,
just a thing. So can we use n naught in place of n? Like they specified n naught denotes natural numbers including 0 in the lecture.
yeah, that's why every time I'm including 0, right?
So put that a naught also, like n naught, sign of
No,
naught.
that we can't mention. So you'd have to train your mind now in such a way that everywhere
Okay,
it is, because I can write here n naught, but in
Mm.
the exam it will be written as n. Then again you'll get confused, right? So it's
Thank you
better.
so much, sir.
Yeah.
I'll get it.
Yeah. Okay. So because I can write it here, but in the exam it will not be mentioned, right? It'll just be, nobody is going to mention that, right? Because it has been taught, like here it has been taken. The convention is taken in such a way that that includes 0 already. Okay.
Yes, got it.
Okay.
Sir, I have a doubt in transitive.
Yeah. Go ahead. Ask your doubt.
Sir, you have given me an example, R3 example. Why it is not transitive?
Okay, here you are talking about this, which example? This one, huh?
Yes, sir, this one.
Okay, why it is not transitive? Because see, if you see 2 1, right? 2 1 is present, right? You have to search for yeah, 2 1 is present, correct?
Yes, sir.
For
Yes,
2
sir.
1, 1 2 is also present, right? If 2 1 and 1 2 is present, 2 2 should be present, correct? See,
Yes, sir.
if 2 1 is present and 1 2 is present, then
Yes,
if
sir.
xy is present, yz is present, xz is what? 2 2, correct?
Two.
Xz
Yes, sir.
is got 2 2. 2 2 should be
Yes.
2 2 is not there, so it's not transitive.
Yes, sir.
Clear, right?
Okay, sir. Yes, sir.
Okay.
Sir, in that question,
Yeah.
sir, there is 2 1 is present and 1 4 is also present. Sir, and sir, 2 and 4 is also present. Sir, doesn't that make a transitive?
No. What did I say? See, 2 4, 1 2 is present. Sorry, 2 4, and then what is there? 4 1 is present. That like 2 1 is also present. That doesn't make see for each and every pair that should be present. See, for each and every xy, yz, xz should be present. So it is a necessary condition. So x for each and every pair of xy, yz, xz should be present. Even for one pair it is not present, you can just cancel it out.
Okay, sir. Thank you.
Right? So for let's for example, there for all pairs it is present. But for only one pair, if it is not present, you can directly say that it's not transitive.
Okay, sir.
Yeah. Now, see, so we have dealt with the relation. I hope in coming session we'll be coming out with some of the more examples that will give you more clarity about the relation. Maybe you are getting confused some of the time, right? As of now, we have just dealt with very basic stuffs about the symmetric, reflexive, and transitive. I just gave you some of the very basic examples and all. Real life example, maybe in the coming session and all, I'll be coming up with some real life examples like we did it, like the level 1, level 2, and that type of questions only will be asked. Nobody is going to ask you like they'll be giving you R1, R2, and then binary relation and all those things. They'll not be giving you. They'll just give you the real life examples only, and then they'll ask you, okay, whether this relation that I have defined, whether it is a reflexive or transitive or symmetric or not. Okay, so we'll just solve some more problem and then you'll be clarified with that. Now we have dealt with the relation.
I have one question.
Yeah.
So suppose above questions. Suppose A is a non-zero integers. Then that case is what is the cardinality?
N is a
zero integers.
Okay, non-integer. Then you can put any values, right? Between 1 and 2, you can put n number of values, right? You can't have, right? So 0.1, 0.2, 0.3, you can just keep on putting, right? All are less than equals to 0 and 10 equals, right?
Okay.
And you are saying that you are just saying that S includes all the values from 0 to 10. That integer doesn't matter, right? Those are not integer. Like it can be, so 1, 2, 3, 4, 5 from 0 to 10. Those integer are not there. All the other values are there. That is what you are talking about, right? That is what you have said, right? Are you there?
Yes.
Then you can have n number of values. Like you can have a uncountable number. Let's for example, right? Your S is what? Your S is all the values except 0, 1 till 10, right? You have like 0.01. So all the, so from 0 to 1 itself, you have an infinite number, correct? And if you'll just put it y equals to x square, right? You can put any values, that will be y also will be between 0 to 1 itself. So you can have put any values, you just put it out and you'll be having y also as x cube. Let's for example, you're putting y equals to x cube. You just put 0.01. The value that you'll be getting 0.01 whole cube, right? So this will be 0.1 comma 0.1 a whole cube. That will also be not integer, correct? Right? So that will also be one value, one cardinal. Second value, 0. Let's for example 0.1. So you can have an uncounted, like infinite values you can have. So you can't count it out. You got it right. Okay. Any
Excuse me,
other
sir.
doubts anybody has? Yeah.
Sir, I have a doubt that like if we have in this relation we have give the questions in definite form. Is it possible if we give in from 1 to infinity?
No, they can't give you 1 to infinite, right? Because how will you get the answer then? If you have to calculate the number of cardinality, if they are giving 1 to infinite, there must be some condition that they will give, right? Such that the number will be countable, maybe on a fingertips. Your answer will mostly will be what? 0 to 10, 15, 20. Over that, you can't, humanly, you can't count, right? In that limited time, 45 minutes or 1 hour, right?
I got it.
You got it,
Okay,
right?
thank
Yeah.
Yes.
Sir, I've shared one photo in the chat, the questions photo. How is this transitive?
Okay, just give me a minute. What is this question? Both you have selected. Okay. So is this a graded question or what? This is not a graded, right?
This is assignment question, sir.
This is
assignment question.
No, this is assignment question, not a
Assignment
graded.
question.
This is not graded. Okay, then we can discuss this. Yeah. So here it has been said a relation has been defined, right? As snail, frog, bird. Okay. What's your doubt here? What is the doubt?
Why the relation is transitive?
Why the relation is transitive? So let's for example, for a snail, frog, right? You just search it out. Anything that starts from frog, no. Correct? Now for the second case, bird, bird, right? So that is fine. Fox, frog. Anything starts from frog? No. Snail, fox. Anything starts from fox? No. So there is no condition that should be fulfilling, right? There's no AB, BC that AC should be present, right? Are you getting me?
Okay, so
see AB,
okay, got it.
if AB is present and BC is present, then you have to check for AC. If BC itself is not present, you don't have to check for AC, right? So here, snail and frog is present. Anything that starts from frog, no, correct? See, for AB, B, anything, if you have element AB, what you have to search? You have to search for any element that starts with B, correct?
Okay.
Yeah. So and
bird element has no problem with it, no?
bird is there. Anything else that starts from B, bird itself, right? So if let's for example you're just taking bird as AB and bird itself as BC, right? Then AC is also present, right? That is bird itself, correct?
Okay.
Yeah. So now similarly you can just take it for fox and frog. Anything that starts from frog, no. Correct? Now the fourth case, snail and fox. Anything starts from fox, no. So this
Starts
is
at
the
fox frog.
Starts
Sir,
fox
yes, sir.
frog.
Fox frog.
Fox is
Fox
start.
frog is there, but again
okay.
snail
Sorry.
frog is
Yeah.
also there.
Correct. So a snail fox is there, and then fox frog is there, right? So now you have to search for what? A snail frog. Is it there? Yeah, the first case is there, snail frog. So this is a
Yes, sir.
transitive only, right? Is this clear to whoever was asking the doubt?
सर आपने बोला था कि ऑर्डर मैटर करता है तो सर इसमें स्नेल और फ्रॉग को ए और बी मानते हैं तो
हाँ
फिर ऑर्डर चेंज होना चाहिए ना
कहाँ चेंज हो रहा है? Like where it is changing? Snail fox is there, correct?
यस सर
Snail.
सर या अगर पहले से स्टार्ट करते हैं स्नेल और फ्रॉग से स्नेल को ए लेते हैं और फ्रॉग को बी लेते हैं
Correct. Is there any element that starts with frog?
No,
Is there
sir.
any element that starts with frog? No. Correct. So let's move to the second part. Bird. So that is it's fine. Fox, frog. Anything that starts with frog?
तो हम लोग सर सारे एलिमेंट को चेक करेंगे ना सारे
सारे को
एलिमेंट
check करेंगे. Each and every. That's why I wrote it. Like that's why I'm writing each and every definition. Though that will not be confusing for you. For each and every element, like for each and every pair, you have to check. A, B, B, C, A, C should be present. If A, B is present, B, C is not present, you don't have to check it for A, C. Okay, clear? Whoever was asking the doubt, is it clear to you?
Yes, sir.
नो सर यहाँ फर्स्ट एलिमेंट में स्नेल ए हो गया फ्रॉग बी हो गया तो सर हमें बी और सी भी तो देखना होगा तो बी कहाँ है फ्रॉग तो है ही नहीं सर किसी एलिमेंट में
तो तभी
फर्स्ट
तो बोल रहा हूँ. That's why you don't have to check. If you're
Yes,
just anything that doesn't start with frog, okay. So what is the condition for a transitive? The condition is if AB is present, okay, and BC is present. So that is and, not or. So AB, BC is present, then you have to search for AC. If only AB is present, you don't have to check for BC also. Like if BC is not present, you don't have to check for AC. Okay.
Okay, sir.
You got it right. Okay. So I hope this is clear to everybody.
Yes,
This
sir.
example, whoever is asking, is it clear to you?
Yes, sir.
Okay, thanks. Let's move to the which part? Function. Okay. No, there was a question. I don't know whether you have checked it or not. There was a question that is also a good question. Maybe you can just solve that question. There's a question in a practice assignment. You'll be checking. It will be something like Devendra has 3 sons, Jatin, Ravi, and him, something like that. Okay. Try to solve that. If you are able to solve it, that one, then it is good. Like you are able to understand everything. Okay. Solve that question particularly. Okay.
Flowchart question, right?
Flowchart. Correct. Okay, let's move to the function now. See, so we have learned about relations. Okay, so we are done with the relations. Now the function, see, whatever you were having n number of relation, right? So let's, for example, you were having a Cartesian product A cross B. And relation R1, R2, whatever you were writing, that was what? A subset of A cross B, correct? This we already know. So a set has been defined, a different set has been defined, all the mapping that you were having, okay, whatever the mapping that you were having, that was some sort of a relation. So you can have an n number of relation on A cross B. But out of that n number of relation, you will be having a very fixed number of functions. Correct? See, let's, for example, a mapping y equals to x square. X square equals to y equals to x cube. So these are all what? These are all relation. But out of this relation, there can be some fixed number of functions only. Are you getting me? So
Yes,
for a function, now we learn about function. Which of the relation are functions? Okay. So function is nothing but function is a relation itself. So now I'll define.
So function is a special type of relation.
Correct. Function is nothing but a relation. A function is a relation only in which each element in some sort of a, let's for example, some set X is mapped with exactly one element. In Y. Okay. So what I'm trying to say is, let's for example, a map X has been given, a set Y has been given to you. Here the element 1, 2, 3, 4 has been given. A, B, C, D has been given to you. Okay, so A is mapped to B. Let's for example, 2 is mapped to C, 3 is mapped to A, and 4 is also mapped to C. Is this a function or not?
Yes,
Not
sir.
a function.
It is a function.
It is a function.
Yes, sir. It is a function.
Yes,
What
it
is the
is a
definition?
function.
Unique
I said?
mapping.
Yeah, correct. Each element in X is mapped to exactly one element. So you should not be getting confused that why 2 and 3, 2 and 4 both are mapped to C. That is not the case. What I'm saying is each of the element in X is mapped to a unique Y. So 2 is mapped to C. 4 is also mapped to C. That is fine. 2 should not be mapped to A and B both. Are you getting me? See this. Okay, so
Yes,
this is
sir.
one example. The second example I'm writing it as, again the same thing, 1, 2, 3, 4, A, B, C, D. So A is mapped to B, 2 is mapped to C, 4 is mapped to C, 3 is mapped to D. Okay, and then 3 is also mapped to A.
Not a function.
This is
Not
not
a
a function.
Not
This
a
is not a
function.
function.
Not a function.
Not a function. Why?
3 is mapped
Because
to I.
correct.
Mapped to
3
two
is
numbers.
mapped to A also, 3 is mapped to D also. That is not possible.
Only one element.
I told you, right? Each of the element of X should be mapped to a unique Y. So 2, if f of 2, I should be knowing what is the value of f of 2?
E.
C, correct?
C, C.
But in this function, what is the value of f of 3? Do you know what is the value
A,
of f of 3?
A or
This is in
D.
some SHM, right? So it can
Mhm.
be A also, it can be D also.
D.
I don't know what is the value. So if that is the condition, then you can directly say that this is not a function, right? If you are putting the value of a domain. So, and one more thing, this is domain. So domain is nothing but if you have some sort of a mapping or a function. So whatever the value that you are putting in the function, that you call it as a domain. Okay. And whatever output that you are getting, that you call it as a range. But here there is something called codomain also. So the expected output is a codomain, and the exact output that you get it as those are range. Okay. So this is nothing but domain, and this is codomain.
ABC is range.
Yeah, and ABC is range because the output that you are getting is ABC. The expected was ABCD both, like all four. Like the output that you exact output that you got is what ABC, that is range. And this is function. This is not a function. Why this is not a function? Because if you have a mapping, let's for example, this was the mapping fx function. So if you are putting the value of f of 3, you don't know what are the value that you will get, A or D. Okay, that's why you can't call it this as a function, but you can call the first example as a function. Clear?
One more thing.
Clear, sir.
All the elements
Yeah, so
in the domain needs to be mapped to.
Is this a function?
No, sir.
No, sir.
No, sir.
No.
Not a function.
Why no? Because I'm just
Because
putting one
each
value,
input
right?
has two outputs.
Correct. If I'll put, let's for example, this is x1. This function of x1, I don't know what will I get. I can get this also. I can get this also. Right? So this is not a function. Yeah. The doubt that somebody was asking. What was your doubt?
My doubt was that all the elements in the domain needs to be mapped to mapped in the codomain.
Correct.
I mean,
That is
all the
also one
domain.
of the condition. That is one of the condition. See, if let's for example 4 was not mapped, then you can't call it as a function because then you can't call this as a domain itself. Because domains are all those values that you can put inside the function. Okay.
Got it.
Got it, right? So if 4 was not mapped, then 4 was not in the domain itself.
Got it.
Yeah. Okay. Now f of x1, you don't know whether it will be positive or it will be negative. So you can call it as a, so there is something called vertical line test, right? If we have a plot and if you are just drawing a vertical line, it should just cut at one place. If it is cutting at more than one place, then directly you can call it as a non-function, like it's not a function. Okay. So you can just check it with the vertical line test also, but that you will be learning the later part. But as of now, if you have been given a plot, then directly you can just drop a vertical line and then check whether it is cutting at one place or two place, like more than one place. Okay.
I think that topic is in week 5.
Correct. Okay, is this clear to everybody?
Clear.
Anybody has any confusion in domain, codomain, range, and all?
So you mean one input has only one output, and one input don't have a different output, two different output.
You can't have two different output. Then it's not a function itself. Okay.
Okay.
Okay. So
But
now,
two different inputs can have one output. The same
correct. That is possible. So let's, for example, this is the case. Right? You can have, let's for example, at this point, okay, let's for example, x1, you can have, let's for example, this is 2. And again, at this point also, x2, you can have 2. Correct? At x1, so f of x1 also is 2. F of x2 is also 2. But this is a function, because if you just drop a vertical line, you'll be having it is cutting at only one place, right? This is not a 1-1 function. For 1-1 function, there is something called horizontal line test. So you drop a line vertical, horizontally. If it is cutting in more than one places, then directly you can call it as this is not a 1-1 function.
Yeah.
Okay, 1-1 function is one input, only one output. This also should not happen. Okay. Is it clear to everyone? So now I'll come to that type of function. So you will be learning. So now to check for a function, you have something, right? You mostly will be given the domain and codomain, like this plot. You can check it, right? If you have for one input, if you have multiple output, you can directly say that it's not a function. Now, if you have been given the plot, you can just check with the vertical line test, and then you can come out with a conclusion that this is not a function or a function. Now, in the type of function, you just have to know about one function that is called it as a 1-1 function. So there is nothing but in each of the element that is there in X, right? That should be mapped to a distinct element in Y. Okay. I hope this is clear. That you call it as a 1-1 function.
Yes, sir.
Got it, right? So this is nothing called if each element in set X is mapped to a distinct element. In set Y. Then this function, you call it as a 1-1 function, injective function, whatever you want to call it as. Okay. And how do you check that? You can check with horizontal line test. Correct?
What is
The
horizontal line
class
test?
end time.
What?
What is horizontal line test?
Horizontal line test, let's for example, you have a function something like parabola going upward. Okay. Is this a 1-1 function?
No.
No.
Right? No. Why?
Because horizontal cuts are 2 points.
Correct. So let's for example, this at x1 and x2, you have same output, right? So why are we calling it as a horizontal line test? Because if you're just plotting horizontal line, that will check what at two different points, it is checking whether you are getting the same output or not. If you are getting the same output, right, that means what, it's not a 1-1 function. That's why we are dropping a horizontal line, and if it is cutting in more than one, then you can directly say that at 2 points you're getting the same output, and that means what, this is not a 1-1 function, and you can't get the inverted. Like there's a reason behind that also, but we will not go deep to that. But yeah, this, if you're just drawing a horizontal line, and if it is cutting in more than one, you can directly call it as this is not a 1-1 function. Is it clear to everybody?
Yes, sir.
Okay, so this is done. There is something called onto function also. Onto is nothing but your codomain should be equal to your range. Okay. So this like, I'll just give you one example. Let's for example, this is X, not X. This is 1, 2, 3, 4. This is A, B, C, D. Let's for example, this is there. Okay, and then E is also there. Okay, so this simply means this is domain, this is codomain. Now, this is not a onto function or surjective function. Why? Because I told you a definition, right? For a function to be onto or a surjective, your codomain should be equal to range. Here codomain is ABCD, but range is what? ABCD only. Correct?
Yeah, E is missing.
E is missing, right? E is not mapped to any value. So you don't know what will be the function value where it will be equals to E. You don't know that, right? Let's for example, there has been given 5 is mapped to E. Now this is a surjective or a onto function because the codomain and the range are same. So f of 5 is E. Is it clear to everybody?
Yes, sir.
So
Clear.
so is this function 1 1? Is this function 1 1?
Yeah,
It is 1 1 also. It is onto also.
it is bijective also.
So bijective is nothing but if a function is onto 1 1 1, you call it as a bijective function.
Yeah.
Is it clear to everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Y
sir.
equals to x square. Is this a function?
No, sir.
Yes, sir.
If y
It
and
is a
x
function.
Like
domain,
it depends
codomain is
what
natural
domain we are
numbers.
taking.
No, domain is like all R to R.
No, sir, it's not.
Yes,
No,
sir.
sir.
It's a
Why this is not a
No,
function?
sir, because negative numbers will not have
Yeah,
same.
Positive will be.
0 to infinity.
Put two different elements in the domain will have same output. Same
Range
is
of a
resulting
function
codon.
is
No,
0
no.
to
Just give me
infinity.
one.
function.
Why this is not a function?
This is function, but one not one to one not function.
Yeah, this is not 1 1 1 1. I'm not talking about that. I'm just asking whether this is a function or not.
Function.
Yes, sir. It's a
Yes, sir, it
quadratic
is a
Yes,
function.
it
function.
is a function.
Yes, sir.
Function?
This is a
Okay,
Sir, it is a function.
Yes, sir.
correct. Whether this is this a 1 1 function?
No, sir.
No, it is
No.
many one
Sir,
function.
many one function.
Okay. Now the domain for this function is from 0 to infinite. Is it a 1 1 function?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now it is.
Domain is 0 to infinite. Why then it is a 1 1 function?
Yes, yes.
Domain is 0 to infinite means how will you plot this? This will be something like that. So now
It's
you can have a
it's
horizontal line test. The horizontal line test will pass. Okay,
Yeah.
correct. Now y square equals to 4x. Is this a function?
Yes.
This is a parabola going right side. Is this a
No, sir.
function?
This is
Is
not
the
function.
vertical line text.
No, sir.
This is
No,
not a
sir.
function.
Not a
This is
function.
not a function itself. This will be something like that, right?
It will fail the vertical line test.
Yeah.
Correct. This is not a function itself. I hope that is making sense to you. So these are some basic function. You can practice it out. We'll just learn about more functions. Difficult, but at least you should be clear with all these function first. Okay.
Sir, will you
Okay.
explain how to find maxima and minima?
Those we'll be learning
Sir,
in week 3. Okay.
Week
There's
3.
sir,
nothing
from
very simple. Those are very simple things, you know.
You can
sir,
find
from the
using derivative.
Okay. So is this clear? The type of function is clear? 1 1 and onto to everybody.
Sir,
Yes,
basically
sir.
from the understanding
Yes,
of
sir.
1 1 and onto functions, can we conclude that for a 1 1 function, the number of elements in domain should be less than or equal to the number of elements in codomain, but for onto function, the number of elements in codomain should be less than or equal to the number of elements in domain.
No, can you just repeat like what you were saying for a 1 1 function?
The number of elements in the domain should be less than or equal to the number of elements in codomain.
That you can say. Correct.
But for onto function, the number of elements in codomain should be less than or equal to the number of elements in domain.
How can you say that about?
Because then only when the number of
No,
elements in
see. So
codomain will be less than the number of domain,
okay.
then only we can say that then only the range being equal to codomain is possible.
See,
If
whatever
it
you said
either
about
it is equal or less.
whatever you said about the range and codomain is fine. So for a onto function, okay, so the range and the codomain will be equal, correct?
Yes, sir.
Right? So then only it is a onto function. But for a domain, right? Let's for example, domain is very large, right? R, correct? And you were having that input that you were getting were just 4 values, 1, 2, 3, 4 only. But for an onto function, there is no condition on codomain, like domain, right? There's a condition on codomain, right? The codomain and the range should be equal. There's no condition on domain. There can be R, and that output value, let's for example, you have a function such a way that you have defined a function such a way that the value from 0 to 100, just putting it out as 1. 100 to 200 is putting out as 2. There's some sort of a function or a mapping has been given to you, right? So you can just say about the codomain and range. How can you say about the number of codomain and a domain? That I don't think so is applicable.
Sir, I like this can be deduced. It's not a वैसे given, but इसको हम conclude कर सकते हैं, extract कर सकते हैं from the understanding, because if the number of elements in codomain is greater than the number of elements in domain, तो फिर जो range होगी, because each element of codomain can only be having one image, right? Like one unique image.
For onto
but
function.
Then there will be for onto function, but then there will be elements left in the codomain. So the range has to be either equal to the number of elements in the domain or less than that. It cannot be more. So we can say that the elements in codomain are less than the elements in domain.
Yeah, you can make that, but I don't think so anybody is going to ask
But
you regarding.
sir,
Yeah.
but
That
sir, we
depending
are
on
as we are
context.
studying real functions, so the codomain will always be real. Is it so?
Your voice is not clear, sir.
Is it?
Sir, your voice is
It's
not
crystal
clear.
clear, sir. It's crystal clear.
I don't think so. I don't think so. There is any issue from my side, but yeah.
The voice is clear.
Yeah. You can come again. Somebody was asking somebody
Yes,
saying
sir.
something.
So, sir, as we are studying real functions, so the codomain always be real.
Yeah, that is always be real. We are just talking about the real things only. We are not dealing into complex number.
So, sir, its size will not reduce according to the domain, because codomain will always have to be real, as functions are real.
Yeah.
Yes, but range can vary according to the domain.
Yeah. See, no. See, what she was saying is regarding the onto function. She was saying that whatever you said, okay, codomain can have a n number of values, and then out of that there will be some range. Okay, that's fine. For onto, both should be equal. The number should be equal. Okay, because that's the only condition that you are putting into onto. Correct?
No, sir. Sir, I'm saying the codomain will always be real. It will not change as we are studying the real functions. Or it will it?
Yeah, that we are talking about only real values only.
Okay.
Yeah, we are just talking about the real values only.
Which means y equals to x plus iota y is not a function.
Y equals to?
X plus iota y is not a function.
No, that can be a complex function, but we are not dealing with that.
We are not dealing with it.
Okay.
Yeah.
Someone has said that
we're just talking about the real function, real values, real numbers and all. So that's why when we are talking about the numbers also, see, complex can have a n number of things, okay? But those are, we are not talking, we're just talking about the real values, real number, real functions, that's it. Okay?
Okay, sir.
Okay, so I hope the basic idea, I hope, is clear to you guys. You can just practice it out. Try to solve each and every problem that you have for the practice and the graded, you have to solve it and submit it out. But practice, at least try it out, solve it out. Tomorrow again we'll meet, and whatever doubt that you'll be facing, you'll be try to sort it out. All the activity questions, all the practice question, each and every activity and practice question, you have to do it out. Maybe by today or tomorrow, if you have done it, that's nice. Whatever doubt you have, we'll start from the activity 1 and then we'll go to whatever doubt that you have.
Hello,
Yeah, go ahead.
Can you suggest me any book for the practice?
No, there is no book. There are a lot of questions already present, right? You can practice all the questions. Okay, minimum it will be having some 50-55 problem, more than that. Then what you can do is maybe I'll just ask the TA to share you some of the previous year questions also. Okay, week wise. That you can practice it out, and that is more than sufficient. Okay, you don't have to do PhD in 1 week itself. Okay,
Hello, sir.
So it's like yeah. So it's just that you should be knowing the concept. And in the exam, I told you, right, from relation and function only, the questions will be asked. Sets, numbers, all those things are very basics. I hope you are already aware of those things. Nobody is going to ask you also. Mostly in the exam that you will be seeing, the topics gets repeated again and again. The same thing, the relations. They'll ask you different type of relation. They'll give you condition, then they'll ask you to which of the condition that satisfied. One thing that is missing is set theory. That maybe we'll just discuss tomorrow. Some questions, okay, from the set theory, that union intersection, that they generally
Counting
ask
problem.
regularly. Yeah, they ask generally about the
Hello,
union
sir.
intersection. So those things you must be knowing.
Sir, good evening, sir.
Good evening.
Sir, I just wanted to tell you that I'm from a non-maths background and I'm finding it quite difficult to follow up with the week's content as I haven't done both with the 11th or 12th mathematics. But from past few weeks, I have started with the NCRTs. But sir, still I am unable to solve the questions. It is not like that. It's going beyond my capabilities, but I am unable to solve the questions of the activities and assignments. And sir,
if you are able to do that, that is more than sufficient. What I am trying, so there are some questions, those are really difficult, that have been just skipped it. Okay, if somebody is able to do that, is well and good. If you're not able to do those difficult, you can just try it out. There are some questions, those are really difficult. Okay, those type of questions we generally never ask in the exam. If you just go through the previous term paper, you'll get an idea that the papers are much easier than the practice or the graded that you have been given to solve. Okay, you can, that will give you an idea about the topics that we are talking about. And so whatever we have discussed today, if you are able to understand those much, okay, and solve the activity and the practice, like some questions are really difficult. Those if you are not able to do, you don't have to be upset about that. Okay.
एंड सर मैं ये कह रहा था कि सर ऐसा नहीं है कि बिल्कुल ही मतलब मुझे
No, I'm getting your point. I'm
Yes.
getting your point. You have, if somebody has studied bio, right, in 11th, 12th, you would have studied in 10th and all, right?
Yes, sir.
Whatever we are discussing is not as difficult as maybe JEE advanced and all, something like
जी
that.
सर, मैं सर कुछ टॉपिक्स निकलते तो सर मैंने पूछा दोस्तों से, तो वो कहते हैं कि मतलब जी के वीडियोस देख लो या किसी और एनसीईआरटी को फॉलो कर लो या कोई अदर बुक्स बताते हैं। सर मेरे को कुछ भी हेल्पफुल लगा नहीं सर ज्यादा।
No, what I'm saying is you come and attend all the sessions, okay? See, after some 3-4 weeks, right? I'm telling you, whatever doubt that you are facing, right? 4 to 6 every almost 4 day a week, the session is happening, right? You can ask any doubts that you have. A very simple doubt also you can ask. Very less people joins, like maybe in the starting 2-3 weeks, 2-3 like sessions and all, the numbers will be very high. But
Yes, sir.
later, that is the normal behavior that I'm seeing for the last, like, I've been there for the last 5 years, right? I've studied from IIT Madras itself, like 21 batch pass out. So, and then, so the number of students that will be decline, okay, after maybe 2-3 weeks, okay? So you can be there, you can attend all the session, you ask all your very basic doubt also. That is
Sir, can
totally
you
fine.
suggest me what I can do for now? Sir, because sir, there's not only one subject that I can hook up with all day, as there are all other subjects to cover. Sir, can you suggest me, sir, what I can do?
No, I'm telling you, just follow the lectures, okay, and then the live session. That is more than sufficient. After that, you'll not be getting any time to solve any other books. You don't have only one subject, right? You have stats also, you have computational thinking also, right? So at least these three are the very like that will take time, right? CT also, the computational thinking also you'll be learning for the first time, so that also will take some sort of a time, right? Stats, okay, stats and maths are not that difficult. Like even maths, okay, first week maybe you can feel a bit bulky. Second week is very simple. Third is very simple. Even fourth is very simple. So all the other 3 weeks are very simple. The first only maybe for the first time, if you are learning about the relation function and all, it might feel a bulky. But second weeks again, the straight line and all, class 9th and 10th we have learned about that. Quadratic equation, how to calculate the minimum maximum. There is only 2-3 formulas that you have to keep on repeating the whole week. Okay, so that is also very simple. And the polynomial also, the fourth week. So the syllabus for the qualifier is very simple for maths and stats. Computational thinking only is the new one that you'll be learning. Okay, so you don't have to just give it, you have to learn like 2-3 books and all, nothing. Just go through lecture, live session, attend the live session, and then solve the activity and the practice, right? Each and every question you should be knowing from the practice and graded. Okay, and that is more than sufficient. I'm telling you, you don't have to go here and there. If you're just going here and there, 2-3 books you'll follow, I don't think so that is feasible or humanly possible in 1 month. And that is not, like, you just practice whatever has been given multiple times. That is more than sufficient.
Okay, sir.
Yeah.
Thank you, sir.
Okay.
Sir,
Thanks.
thank you very much.
Thanks.
Hello,
Thanks.
sir.
Let's.
When will we doing the sets?
Okay. Tomorrow we'll be
Thank you
learning
for
about
teaching us, sir.
We'll be learning tomorrow about the union intersection and all, set theory and all, basic things, and then we'll take all your doubts that you have. Please try to solve each and every problem that you have from activity, practice, and all. We'll be solving it in like whatever doubts that you have. All those questions we'll be solving tomorrow. Okay.
Okay, sir.
So
Thank you.
let's Thanks.
Sir,
Thanks
I've
everyone.
shared an
You are
image. Can
awesome,
you
sir.
explain that one?
What?
I've shared an image in the chat section, and I just have this set notation doubt. Can you explain that one?
Yeah. What's the doubt?
I've shared the image in the chat section.
Yeah. What is the doubt here? X belongs to R, right? Such that fx belongs to R. What is the doubt here?
Not that one. I've said recently that f of x is equal to mod x plus 5. It's an activity question.
Okay, so fx equals to mod x plus 5, right?
Yes, sir,
This is a function.
I have underlined that set notation. Can you explain that one? Sir?
So there is a function that is defined as mod x plus 5, correct? So the function is defined
Yes,
in
sir,
such a way. And
yes,
the domain of a function, so this is written as domain. So this is domain of a function. Domain of a function is what belongs to x belongs to R.
Yes, sir.
Correct?
Yes,
So
sir.
the domain of a function for that domain, so this is given, right? So domain of a function is what? R, in such a way that the function fx belongs to R. So whenever you are putting something, so x, the domain is also R, and whenever you are putting in that function, right, that also will coming out to be some R, real number only.
Okay, so,
So the fx
basically
is
this
y.
notation represents the domain of value of domain of the functions, and as well the range for the range of the function also.
What?
I'm saying that this function
Okay, can you
domain
just
of
tell me which question is that? Question number?
question number 2 from I think it's 1.9. Yes, activity 1.9, question number 2.
What I am saying that if you learn some basic graphs such as mod and sinus.
Yeah, it has been given something. Yeah, domain, the x, so domain for this, the first option is given, right? You marked it correct only, right?
This I was not able to understand this notation. I was confused about that.
Oh, okay. That is fine. See, here it has been given the domain of the function x for the domain of the function fx is a real number itself, and then when like such a way that the fx also belongs to a real number only. Okay.
Okay, sir.
Yeah.
I was actually confused
But
about
see
it
the
was
confusion
representing the
why,
domain
because in the question itself it is not mentioned correctly. Like it is mentioned correctly, but it's not mentioned like the way it should be mentioned. Okay.
Exactly, sir. I was
Yeah.
confused there.
So that is fine if you're not able to get like, yeah, because this is not how the it should be framed. Yeah.
Yes, sir. And similar question was there, so I was a bit confused about it. Thank you, sir.
Yeah, but in the exam and all, I'm making sure, right? In the exams and all, there won't be any questions that will be confusing. Like at least in reading point of view, there won't be any question that will be confusing. Okay, so I've already gone through the paper. There's nothing that was confusing and all, and yeah, so those are very fairly simple questions that has been given for the qualifier paper. Yeah.
Yes. Okay.
Okay.
Sir, can you share me the previous year questions?
Yes, sir. Previous year question, if it can
I'll
be
just
shared
ask
to
the
us.
TA to share it. Yeah, they'll
Okay, sir.
share you some paper. Yeah.
Okay.
Okay.
Thank
But there are some websites where I'll ask him to share you the website where you can go and practice like a mock paper and all. All the papers are already available. So some of your seniors has made that website and then uploaded all the papers that are available. So that he will share with you. Okay.
Sir, how they will share, sir? Will we get any?
In tomorrow's session you have 4 to 6, right? I hope tomorrow you have.
Yes, sir.
Or whenever you have a next TA session, he will share for sure. Okay.
Tomorrow,
thank you, sir.
4 o'clock session, sir. Tomorrow.
Yeah, tomorrow if you have 4 to 6, yeah, he will. Yeah, tomorrow he will share with you.
He has shared. He has already shared.
Hello.
If he has shared, that is well and good.
Hello.
If it is not shared, then also he will share with you. Okay, tomorrow.
Hello.
Yeah,
So may
yeah.
I
Sir,
order?
I have doubt.
Yeah.
Hello.
What's your doubt?
Sir, all activity question are covered.
Hello, sir.
Yeah, yeah.
So, sir, you said that
like PYQ and practice assignment, graded assignment is enough. So after qualifier exam, through the BS degree program, so is that enough, or we have to buy any books?
No, there is no books. We'll provide you a books also. Provide you book means we have written some book that
Ebook.
contains all the concepts, whatever has been taught. Okay, those books is sufficient. Okay, we'll be having a lot of all the questions also has been compiled. That is also 200, 300 pages of questions itself, that you can solve it out. That is more than sufficient. You don't have to go, and because this has been not been crafted from some book. Okay, so this whole content, like you will be seeing that there are some concept of those you can't find it out in normal mathematics books and all that you'll be learning in the last 2, 3, 4 weeks. Okay, so it's better to just go through the content, and whatever we'll be providing, that is more than sufficient. And whatever doubt you are facing, live sessions has been made to clarify all your doubts itself. Books and all, there are books. Okay, maybe the TA session I'll ask them to share the books also. You can just go through it. Those are some not a very detailed notes, some sort of a short notes you can just think of whatever has been taught in the lecture, with examples, with a bit of detail, not much detail, but yeah, brief about each lectures with some examples has been given. That is more than sufficient to understand it. Some examples has been given to understand the concept, and then you can solve it out the problems, right? Activity, practice, those are more than sufficient. How many problems will you be solving? It's more than 50, 60 problem per week is more than sufficient, right? You have a lot of other questions also, right? You can have might be many of you might be doing some other courses, so that also you have to tackle. And then here also 3, 4 courses in a month, like in a term, is really difficult to tackle, right? So I hope you are able to understand that, right?
Yes, sir. Yes.
Okay. Thanks everyone, and let's meet tomorrow. So we'll just solve some problems.
Hello.
And then yeah.
Okay, sir. Thank you.
Sir, what is TA session?
What TA? Yeah, TA session is generally has been some of your seniors only will be taking the sessions where he'll be taking out whatever doubt that you are facing, right? He'll be solving all your doubts that you have. Even though in our session also he'll be solving the doubts, but those sessions are specifically made for the doubt clearing sessions. Okay.
Sir, mathematics class, live class is only 3.
3 sessions per week.
Yeah.
And 4 other sessions are also there. So 4 sessions, those are also very good people. Like if you will just check, like attend the session, there are very good people. They'll sort out all your doubts that you have. Okay.
Sir, I'm doing job, so it is convenient for me only to attend the lectures in the evening. So can you please request to take all the TA sessions in evening only?
No, that is not possible. So we can't. You can just go through the lectures later, but that is not possible to sift the sessions now, because if you sift it, that will just there are other courses also that happens at different timing, and then it becomes very difficult for us. So that's why we have just sifted this session. The important sessions, those are also important, but these are the 3 sessions that we have kept it as 8 to 10, so that everybody will be free by then. But those session 4 to 6, if you have doubts, so those are the session. If you have doubt, you can just attend one of the session. So there are some sessions that those are on the Saturday, Sunday also. So on those days, if you don't have a work, you can attend those days only to sort your doubt. Are you getting me? There are sessions on the weekdays also, but we have kept most of the session on the weekend also, so that if somebody is working or doing some having some other degrees also, they can attend on Saturday, Sunday. Okay, we can sift that session. Yeah.
Sir,
Sir,
what
is there any sort of attendance
tutoring?
criteria for these sessions?
There is no attendance, nothing. Okay, if you want to attend, you can attend. If you are able to understand with the lectures, able to solve it, everything, you don't have to attend. That is well and good, right?
Sir, what is tutorial session?
Those are some of the examples that has been solved. Okay.
Yeah.
Okay, I hope we are done. I'll also go for the dinner, and you also go for your dinner, and have a good night, and we'll meet tomorrow. Okay, bye. Thanks.
Thank you very much.
Thank
Sir,
you.
you mean, sir, I have question, sir.
Can we do it in the tomorrow session?
Yeah, but
Okay. So yeah, we'll meet in the tomorrow session. Thanks everyone, and bye.
Thank you, sir. Good night.
Thank you, sir.
Thank you, sir. Ganesh.
thank you. Hello.